our pavement design. Okay, so first thing we'll be looking at before we go ahead to design our pavement, we'll be looking at getting our effective resilient modulus when we are given our relative damage factor. So let's take a problem. So the question says, determine the effective resilient modulus in accordance with the AASHTO guide for design of pavement structure using the following monthly resilient modulus data. So we have data, we have different months, it's from January to December, and we have the resilient modulus in megapascal. So we are asked to determine the effective resilient modulus. Okay, so after getting given parameters, so from the question we are given from the month of January to December, we are given the following resilient modulus in megapascals to be these values up to December. So to get our effective resilient modulus, the first thing we do is to get our resilient modulus in pounds per square inch, which is PSI. Okay. So from the question we are given that 1 megapascal. Okay. So we have 1 megapascal to be equal to 145.63 pounds per square inch. Okay. So we have to convert our resilient modulus in megapascals to pounds per square inch. So to convert this to pounds per square inch, so for January, our resilient modulus in PSI is simply equal to what? 86 times 145.63. And that will be equal to what? 12524.18. So let's just stick with the whole number. So this will be 12524. So for January, our resilient modulus in PSI will be 12524. Okay. So the next month we have to compute is for February, but we can see that February we have the same value. So from February till April, and November and December will still be 12524. Okay. So after getting our values for the months that we have the same resilient modulus, the next we have to get is to get our resilient modulus in PSI for the months that we have different values for it. Okay? So for May, from May till October, we have resilient modulus in megapascals to be 103. So computing for May, okay, for the month of May, our resilient modulus in PSI is equal to 103 times 145.63. That's equal to what? 14999.89. Okay, so we can go with this to be 1,500. So now for the month of May to be 1,500. 15,000. 15,000. Okay. So the way that from our June to our October is the same value. We simply have 15,000 for the respective months. Okay, so after getting our resilient modulus in PSI, the next thing we have to get is our relative damage factor. Okay, so we have to get our relative damage factor. And the relationship between our relative damage factor and our resilient modulus is given as Okay, so our relative damage factor is equal to 1.18. This value was determined by ASCO in 1993. So our relative damage factor is equal to 1.18 times 10 raised to the power 8, all multiplied by our resident modulus raised to the power minus 2.23. So with this, using our resident modulus value in PSI, we'll be able to compute the relative damage factor for all the respective months. So for the month of January, we have our relative damage factor to be equal to 1.18 times 10 raised to the power 8, all multiplied by 1, 2, 5, 2, 4 raised to the power minus 2.32. So 0.0336 what? 7. So 367, so 0.037. Let's go with that to 0.037. Now, there's something we should observe. Since our resident modulus for January till April, November and December is the same, meaning our relative damage factor for those respective months will also be the same. So we don't need to calculate for all the months. So for January, we have it to be 0.037. For February, same. Okay, for the month of March, okay, so after putting in the relative damage factor values for those months, the next we need to calculate is for the other months having different resident modulus value, which is from May. So we are taking May. So from May, our relative damage factor is equal to 1.18 times 10 raised to the power 8 multiplied by 15,000. That's going to be equal to what?
0.024.
0.024.
Raised to the power minus 2.32. 1,500.
It is raised to the power minus 2.32. Okay, yeah. So this is going to be 0.024. So for the other ones having the resident modulus to be 15,000, we'll be having 0.024. Okay, so having gotten this first step, remember the question said we calculate the effective resident modulus. So the next thing we have to get is to get the average relative damage. Okay, so how do we get that? We are getting the mean of the damage factor. So we simply add all the values of the relative damage factor and divide by total number. So we have 12 values for our relative damage factor. So it will be this plus this plus this plus this to the end, divided by the total number, which is 12. Okay, so average damage factor is equal to, now we're adding this plus this plus this to the end, but if we observe from our problem, instead of writing this out expressly, we have how many of this value? We have 1, 2, 3, 4, 5, and 6. So adding all this, we can simply say this is what? 6 times 0.037, which is adding this, and this. Okay. So remember we are adding all the values. So the remaining value we have there is 6. This other 0.024. And if we check through our table, it's also appearing 6 times. 1, 2, 3, 4, 5, 6. So this will be plus 6 times 0.024. All divided by 12. Okay? So we have our average damage factor to be equal to what?
0.36 over 12. 0.366 over 12.
0.0.
Stop your maths.
366
over 12. Then the final answer is equal to.
Final answer equals to 0.03.
And this is equal to
0.031.
Okay. So having gotten the value for our average damage, relative damage, to compute our resident modulus, we simply use the expression we stated earlier. So we have that this is equal to 1.18 times 10 raised to the power 8 into our resident modulus raised to the power minus 2.23. Okay, 2.32. Okay, so in this expression, if we have our relative damage if this relative damage is in its average form, so if this is the average, then making our resident modulus the subject of the formula will have our effective resident modulus. So from this point, if we take, okay, so MR raised to the power minus 2.32 is simply equal to 1.18 times 10 raised to the power 8. Fully making our resilient modulus subject of the formula, we have this to be equal to our relative damage all over 1.18 times 10 raised to the power 8, all raised to the minus 1 over 2.32. So with this expression, we can get our effective resident modulus. So our effective resident modulus, MR, is equal to, where our average relative damage is 0.031, 0.031 all over 1.18 times 10 raised to the power 8 raised to the power minus 1 all over 2.32. Our effective resident modulus is given as what?
13475.1.
13475.18 psi. So if you wish to convert this to megapascals, we simply do what? Divide it by the given conversion factor. So taking this to, so this MR in PSI, so our MR in megapascal is simply equal to this expression divided, remember we are given a conversion factor to be what? 145.63. So dividing this expression, this answer by 145.63, we have our effective resident modulus in megapascal. So we have that to be what?
92.53.
92.53 megapascal. That's how to determine our effective resident modulus.